So this is a balloon of helium, and helium is a very small gas. We use it in this case to find leaks in high pressure and high vacuum apparatus because it's very, very small. Finds the smallest holes. But just like hydrogen, it's also very, very light. And you know, in the past we used hydrogen to fill balloons for transport, and now you see the Goodyear blimp, sporting occasions, it's filled with helium.
So helium is probably the most unreactive of the elements. It has a mass of 4, so it weighs 4 times as much as a hydrogen atom, but hydrogen exists as an H2 molecule, whereas helium exists as isolated atoms, so that a helium molecule weighs twice as much as hydrogen.
So here we have a helium-filled balloon, and it's extremely light, so I'm not going to let it go right now, so I will lose it to the ceiling. So we're just going to put on a piece of string, tie a lead around it again.
Helium cannot be synthesized in nature because it is just an element. It is found as a component of natural gas in some places, particularly in the United States, because it is formed by the radioactive decay of minerals in underground, and these form helium, which is trapped with the natural gas.
So here we have our helium balloon floating because it's displacing its volume of air, and it'll float quite nicely. It's actually quite hard to contain, so the piece of string and the heavy stand is there holding it down, because we don't really want to lose it. If we take a balloon of another light gas, and that's hydrogen, and we add a match to it or we set it on fire, it'll burn really, really quickly and really energetically because it makes lots and lots of water, hydrogen plus oxygen. Now we're going to do the same experiment now, but we're going to do it with a helium-filled balloon and see if that'll burn. So here we have our technical match on a stick, and we're going to offer it up to our floating balloon of helium. Let's see what happens this time. A little bit of a bang, but that's just the bang of the gas escaping. It didn't burn, yeah? It's unreactive, it's an inert gas.
The molecule is very light, so once it is in the atmosphere, it will eventually go out into outer space, so that we are, in theory at least, likely to run out of helium in the eventual future, if it is just released to the atmosphere. So
what I got here is a balloon of helium, yeah? And it's really, really light, and it's displacing a lot of volume. You know? So if I let go of it, it's gonna fly like a balloon. So what we're going to do is I'm going to hold it down here, and Neil is going to cool it for me using some liquid nitrogen. Now you can see Neil is using the gloves because it's very, very cold. Okay, so as he cools the balloon, the gases inside are slowing down, and they take up much, much less volume as we slow them down, and now you can see it's displacing less volume. So the balloon's quite happy to sit on the table. If we stop pouring the liquid nitrogen onto it now and watch what happens as the balloon starts to warm up again, because the gases are gaining more energy and they're occupying more space and becoming more buoyant. So the helium has gone back to the ceiling where it really wants to be.
The helium has a whole series of useful properties. Because it's a very light gas, if you breathe in helium, you then start speaking like Donald Duck in a very squeaky voice.
Helium, fantastic element, very light, very fun.
Because the speed of sound is much greater in helium than it is in ordinary gases. It is also very useful as a liquid. It only liquefies at very low temperature. Its boiling point is minus 269 degrees centigrade. But if you cool things with liquid helium, you get very strange properties. For example, some materials lose their electrical resistance. So liquid helium is used for magnets when you need very powerful magnets. And for example, they're used in magnets for magnetic resonance imaging in hospitals. If you use a vacuum pump to pump hard on the helium, the boiling point will go even lower, and you can go to nearly 2 degrees absolute. And so helium is very important for all sorts of refrigeration.